Refraction, practice problem, page 6, question 11. The picture or the figure 7.1 shows a ray of monochromatic red light in air incident on a glass block at an angle of 50 degrees. State what is meant by monochromatic light. This word is composed by two parts. One is mono, which is a prefix that means one. And chromatic is a word that means color. But the answer is, it's a light with one color. Second question, for this red ray, the refractive index of the glass is 1.52. Calculate the angle of refraction for the ray. To answer this, turn this picture to you. Make sure that you have the boundary line facing you. Now let me look closer. So here we have a normal line, which is perpendicular to the boundary line. And above the boundary line, we have air as a median. And below, we have a glass block. So this is our median 1, and this is our median 2. To calculate the angle of refraction, I'm using SNELL'S law. So SNELL'S law states that the index of refraction of the median above the boundary line times the sine of the incident angle is equal to the index of refraction of the median below the boundary line times the sine of the refracted angle. So my N1 is air, and the index of refraction for air is 1, and the index of refraction for the glass is 1.52. The incident angle, which is this one, is 50, and I need to calculate the refracted angle. So this is 1 sine of 50 is equal 1.52 sine of the angle that we need to calculate. So first, I'm going to divide both terms by 1.52. So I can cancel 152. Now rearranging this formula, you'll be sine of theta 2 is equal, and I'm using my calculator to find the result of this operation. So this is 50 sine divided by 1.52 is 0.5 some decimal. So I'm going to write just 0.5 here, but I will have the result on in my calculator. So we can now use this to calculate the angle of refraction with the inverse of a sine of this long decimal number. So right here, inverse of a sine. So inverse of a sine. So 30.26. I can round to 30. So 30 degrees. The next question, without measuring angles, use a ruler to draw the approximate path of the ray in the glass block and emerging from the block. And we need to go back to the picture. So this will be a straight path if the glass block was not here. So I know this is not a possible path, but I can use it as a reference to draw an angle that will be toward the normal, which is 30 degrees. So should be in this space. So 30 degrees, I can define as this here. So this is my refracted ray. And this is the refracted angle, 30 degrees. Now this will be a path. Now it's asking emerging the glass. So here at this point, we draw a normal line. And now we need to define which angle is this. To do that, it's very simple. You can close this so you can see better. So this portion right here is a rectangle, and this is the diagonal line that crosses this rectangle, dividing the rectangle into two right triangle. So if these, they are symmetrical, right? So they are the same, but the angles is kind of face each other, like a mirror each other. So this is 30 and this is 30 degrees. So this is my incident angle as this ray is about to exit this glass block. So how I'm going to draw or sketch my refracted angle. So I know this is glass, which is more dense, and this is air that is less dense. So for this reason, I can go with a straight line like this. For this reason, the refracted angle at this point is going to be away from the normal because the angle is going to be greater. So actually is about 50 right here. So this is, if you like to calculate, you should have about 50 degrees right here. So let's calculate to make sure this is really 50 or close to 50. So at this point here, my N1 sine of theta 1 change the median, right? Now my median 1 is above the boundary line, is the glass. So the index of refraction of the glass was given the problem is 1.52 sine of this incident angle, which is 30. My N2 now is the air, so N2 in the air is 1 sine of the angle that I want to calculate. So now what I'm gonna do is, so sine of this angle is 30 sine times 1.52, 0.76, and this angle is inverse of a sine of 0.76. So this angle is inverse of a sine, this is 0.76, and inverse of a sine is 49.46, and we can round to 50 degrees. So even though we did a sketch of the angle, like an educated guess, the angle that you'll be exiting the block, we can calculate using Snell's law and confirm that that's the actual angle. Problem 12 on page 7. The figure 9.1 represents a ray of monochromatic light passing through a rectangular glass block. Use the information in this picture to determine the refractive index of the glass. And this picture is not to scale. This is the incident angle and this is the refracted angle. So I'm going to use both angles to calculate the index of refraction of this glass block. So N1 sine of theta 1 is equal N2 sine of theta 2. My N1 here is the air, the median above the boundary line. So this is 1 sine of 45 degrees is equal N2, which is, that's what I want to calculate. sine of the refracted angle, which is 26 degrees. So this is what I want, so I'm going to divide both terms by sine of 26 degrees. Cancel. So my N2 now is the 40. Okay, so this is 45 sine divided by 26 sine equal to 1.61. The next question is the angle alpha on the figure 9.1 is not drawn with the correct value. State the correct value of angle alpha. Let's go back to this picture. So if this is 26 degrees, this is 26 degrees. So now I have my incident angle and I have the index of refraction of the glass, all right, which is 1.61. And I can calculate this angle right here. So in this case, my N1 sine of theta 1 is equal N2 sine of theta 2. My 1 is above the boundary line, so is 1.61 sine of 26 degrees. N2 is 1 sine of the angle now is alpha. So sine of alpha is 1.61. I saved my calculator here, all the digits, so let me use it. Times, I'm gonna open parentheses here, 26 sine equal to this. And now this is 0.7. And my alpha is the inverse of a sine of 0.7, so alpha is 45 degrees. So when I use all digits, so you should have like exactly 45 degrees. So this angle alpha is 45 degrees. So that's the same angle the incident before entering the glass block. Question 15, page 10. A laser produces a ray of blue light of wavelength 4 times 10 to the minus 7 meter and state the speed of light in a vacuum is 3 times 10 to the 8 meters per second. This is a constant number. And I calculate the frequency of the light produced by the laser. The formula that we have that involve frequency and speed and wavelength is this one. V, the speed, go on the top of this triangle because V is like a V upside down, see that? So frequency and wavelength. So I want to calculate the frequency, so just place your finger on F. F is equal V over lambda. There's a fraction here, V over lambda. Now, because this is a light wave, so light wave is part of the electromagnetic wave and they travel with the speed of light. So is 3 times 10 to the 8 meters per second. And the wavelength is 4 times 10 to the minus 7 meter. So I cancel meter with meter, and I'm going to use my calculator here to calculate this value. Is 3EE8 divided by 4EE negative 7, so it's 7.5 times 10 to 14, right? Times 10 to 14. And because meter cancel with meter, we have 1 over second here. And 1 over second is the same as hertz. So the final answer here is 7.5 times 10 to 14 hertz. So as you see, very high frequency. Moving forward, option B. The ray of blue light passes from air into a glass block. The figure 6.1 shows the ray making an angle of 35 degrees with the side of the block. State the angle of incidence of the ray of blue light on the glass. The incident angle is the angle a light ray or any ray makes with the normal. So if this is 35, this is 90 degrees, so there will be 90 minus 35, which is 55 degrees. So this angle right here is 55 degrees, and that's the answer for I. So the angle of incidence is 55 degrees. Next, it says the glass has a refracted index of 1.5. Calculate the angle of refraction of the light in the glass. Snell's law again. So N1 sine of theta 1 is equal N2 sine of theta 2. So now let's identify who is median 1 and who is median 2. So the median above this line is the air and below is glass. So we are talking about 1 here is the air. So that's the sine of 55 degrees. And N2 is the glass, and the index of refraction is 1.5 sine of what we want to calculate, the angle of refraction. So I'm going to divide both terms by 1.5, 1.5, can eliminate this. And my sine of theta 2 is equal to this fraction. So I'm just going to write the decimals here, like 2 decimals. And when I calculate the inverse of a sine for this value here, my calculator shows the angle of refraction of 33 degrees. Now back to the picture. So this is my normal line, and the angle of refraction, so this will be 55, right? 55 will be like this, but my 33 should be about here. This is 33 degrees, and because of symmetry, so this angle is 33 and is going to exit with 55.